I studied computer science engineering at the KU Leuven. After I got my diploma, I started a PhD at the University of Ghent, which was on emission tomography. I did my PhD research there, and I also stayed there for a postdoc for about 2 years. At the end of those 2 years, I started to work also with Professor Seibers from the Vision Lab. And I stayed here for about a year and a half, and after that I transferred to iMinds, which was then later converted to iMech. But I've always been connected to the Vision Lab. I'm married. I have 2 children, a boy and a girl of 10 and 6 years old. And in my free time, I enjoy rock climbing, and I live in Herasbergen. My research is on tomography, and tomography is a technique that allows you to combine different views from an object into a 3D reconstruction of that object. Ideally, you would acquire many hundreds to thousands of images before you can accurately reconstruct an object. But in many cases you don't have this opportunity. Sometimes in medical imaging the dose, the X-ray dose has to be very low to people. So you take as few images as possible. But then that poses a problem, because if you have too few images, you have an ill-defined problem. And that is something that we want to tackle by using parameterized models that fill up this empty space with prior knowledge. And this basically allows you to obtain better images. For example, in electron tomography, where you try to recover atoms in a crystal grid, and this is typically impossible if you use traditional reconstruction methods. But if you use a parametric model, for example, that represents an atom, then you can solve this problem in a very different way, because you simply look at the position of every atom in the reconstruction, which is immediately a group of voxels, and that allows you to improve the reconstruction quality a lot. Last year we obtained funding from the FWO to acquire our own X-ray system. This will be a very flexible system where every component can be controlled separately, and this is basically a hardware equivalent of the software that we develop. And this will allow us to make a very tight integration between those two. And this is important because in the future our research will move towards flexible acquisitions, where you have the opportunity to intervene in the scanning process itself.